Hi, class. You're going to take some notes today. And remember that as I go through this, I might go through kind of fast. And so you need to just continue to pause it or back up or watch something in if you miss something. Remember, you're going to be taking notes on this paper. So please make sure that this is where you're writing notes. You can see there's lots of blanks on it. Fill in the blanks as you go. And again, if you miss something, pause it, back it up, listen to it again. Today, we're going to talk about astronomy. Astronomy has been a subject that has been studied by humans since they did this and tried to figure out what was going on in the sky above them. Some of the earliest astronomers were in Egypt, in China, in the United States, in North America, and some of those native people made some incredible observations, things I don't know how they figured it out. And so here's a couple of examples of some Native American astronomy devices that they created. On one side, you can see what's called the medicine wheel. And what astronomers have figured out is spokes of that medicine wheel point at specific objects in the sky at different times of year, where a constellation will be, where a planet will be at certain times of year. They think they used it maybe as a calendar to keep track of time. On the right, you can see an example of what is called the Blackfeet calendar stick. Obviously, this is not a Blackfeet calendar stick because it's a power pole, but essentially it's measuring the length of the shadow. So in the winter, the sun is very low in the sky, and so shadows get very long. And so you can tell that you're at the peak of winter if that shadow stretches all the way out to letter A on this. And then in the summer, the sun is very high in the sky, and so the shadows are very short. And so if the shadow only reaches out to C, then you know it's the peak of summer. And then B is, of course, for spring and for fall. So ingenious methods. There's lots of examples. You've probably heard of things like Stonehenge and the pyramids in Giza. All of these are tied to astronomy. And so there's lots and lots of stuff. Our astronomy kind of starts roughly about 2,000 years ago, our real study of space with a Greek gentleman. His name was Aristotle. At that time, he was the premier astronomer or scientist, for that matter, of his time. And during that time, there was no technology at all. They had nothing to help them out. And so everything that he did was observation and thought. Just trying to think through problems and figure out what was going on. And so he came up with this idea that the Earth is at the center of the solar system. It's called the geocentric model. The way he came up with that is that in the morning, he would see the sun rise in the east, come across the sky and set in the west. And the same thing would happen day after day. And at night, he would see the moon come up in the east, go across the sky and set in the west. He'd watch the stars move across the sky. He'd watch the planets move across the sky, and they all look like they were going around the Earth. So it was a very easy observation to conclusion for him to say that the Earth was at the center of the solar system and everything went around the Earth, because that's what he was seeing. He also said that all the objects in space are these perfect spheres, perfectly smooth, and no blemishes on them whatsoever, and that all of the objects orbit in the perfect shape, which is circles, and that everything in the heavens is perfect and unchanging. So this material of these objects in space, whether it's a planet or a star or the moon or whatever, they are made out of material that we cannot find here on Earth. And it's perfect material, and it doesn't change. The way that we see it now is the way that it's always been and the way it's always going to be. I talked about that. And his was the first accepted idea for explaining the layout of our solar system. And actually, it was super duper popular with the Roman Catholic Church at the time, because they said, whoa, you're saying that the heavens are made of stuff that you can't find on Earth, and it's perfect and it's unchanging. And we really like that idea. And so we would support your idea. And as a matter of fact, it was supported for almost 2,000 years because of the church, because of some other stuff. But we're going to see how things change. So 1,500 years after this, Nicholas Copernicus, he went to college as a mathematician. He was doing some calculations of the brightness of the sun, and his calculations did not match his observations. And he said the only way that this can work out is if the sun is at the center of the solar system and everything goes around the sun. And so he was very worried about this idea. He didn't want to present it to anyone because, of course, for 1,500 years, people had thought that the Earth is at the center of the solar system. The church liked that. And so the year before he died, he presented this idea. The church, of course, did not like it, but it didn't matter. He was kind of starting to let people know there might be a different way that the solar system is laid out. Around the same time was a Dutch astronomer. His name is Tycho Brahe, and he was the premier astronomer of his time. You could think of him like the Tom Brady of his time, if you want to. He was the best. He worked on this island. He had to raise all his own money to do this. He didn't use a telescope. He did believe that the Earth was at the center of the solar system. And he did some incredible stuff. He designed some of his own equipment. He used all the materials that he could at the time. And he would go out every night and he made these very detailed star maps that today are accurate within 1 degree of accuracy. So that's pretty incredible. No computers, no telescopes, nothing like that. And he also mapped planet locations. And he found some weird things in that, like Mars looked like it moved backwards in its orbit and then back to forward. He was also the first person to record a comet. Now, you have to understand, when he sees a comet, comets, when they're really visible, they show up in the night sky, and they travel across the night sky slowly over the course of a month, and then they disappear. Now, Aristotle, he said that the heavens were perfect and unchanging, and Tycho, he's like, I agree with that, except I'm observing a change. It's very hard for me to figure that out in my brain. And then he also was the first to record an observation of what's called a supernova. And that's when a really big star blows up. And if it's close enough to us, it shows up very bright in the night sky. Like suddenly the star gets incredibly bright. You can even see it during the day. And that happens for a few weeks and then it goes away. Again, a change. So Tycho's recording these things. He can't really, it's trying to fit it into his system of understanding and it's not really working out. But he used all this equipment. He even made some equipment to do all these really precise measurements. So super amazing, all the stuff that he did 500 years ago without computers, without technology, without a telescope. Good stuff. He has this crazy backstory. He was trying to raise money to do his observations, and he went to this really rich person's house, and you're not supposed to leave the table until they do, and he was eating and drinking, and he had to go to the bathroom, and supposedly the theory is that his bladder ruptured, and that's how he ended up dying. Before he died, there was a guy named Kepler who went to college to study mathematics. Johannes Kepler was like the rising star. Think of him, if Tycho Brahe is the Tom Brady of astronomers, then Kepler is like the Patrick Mahomes. He's the up-and-comer, and he was working with Tycho, and then Tycho died, and he used his planetary data, and he turned it into his 3 laws of planetary motion, which we use today still to understand how objects in our solar system work. So the first thing he said was that planets orbit in an ellipse, not a circle, but an ellipse. That's E-L-L-I-P-S-E, ellipse. And that's in the first diagram on the left. The second thing, his second law said that when a planet is closer to the sun, it orbits faster. When it's farther away, it orbits slower. And his third law said, if you know how long it takes for a planet to go around the sun, you can figure out how far away it is. Or if you know how far away it is, you can figure out how long it takes to go around the sun. So that's pretty cool. This was Tycho's explanation of how the solar system worked, because he had all this data that wasn't jiving with the geocentric model. So he took everything and he had it orbiting the sun, except for the moon, which went around the Earth. And then all of that orbited around the Earth. And he was like, oh, okay, that works for me. So Tycho Brahe, he made that work out for him. All right, about 100 years after them, an Italian gentleman, his name was Galileo. Galileo provided evidence now that the sun was at the center of the solar system. So the way that he did this was that he used a telescope. He had heard of somebody else using this telescope to look for ships coming into port, and he thought to himself, well, maybe I can use it to look at stuff in space. And so he built his own, and he did that, in fact. And he made 4 observations with this. He saw that the sun has spots, and the spots come and go, which in the Aristotle system doesn't work, because then spots are not a perfect smooth, and there's change, okay? He saw that the moon has craters, which means the moon's not smooth. He saw that Venus has phases, like the moon has phases, a full moon and a quarter and a half and all that kind of stuff. And that can only happen if Venus is going around the sun instead of the Earth. And he also saw that Jupiter had 4 moons. And that means that those moons are going around Jupiter and not around the Earth. So he had all this hardcore evidence that showed that the idea that the Earth was at the center of the solar system was wrong. The other thing about Galileo is he didn't have any problem telling people that he was right and they were wrong. And that was kind of his deal. But the thing you have to remember is he was also telling everybody that the church was wrong, which at that particular time makes you a heretic. And when you're a heretic, they tend to pile a bunch of wood and burn you at the stake. And so there was this, the historical records show there was this meeting between Galileo in Rome with either a high-ranking cardinal or the Pope himself. And they said, well, your evidence is overwhelming, but we can't come out as an entity of the church and say that we're wrong. So we'll make you a deal. We won't have you killed as long as you don't speak or publish or teach anybody about this information anymore. And you need to be on house arrest for the rest of your life, which is indeed what happened. And Galileo still did some good stuff. He started the science field of physics. And so that was pretty good, even on house arrest. All of this made possible by advancements in technology, whether it's using math, using the equipment that Tycho Brahe did, or using a telescope. All of these changes were because of increases in technology. And that's how astronomy has developed over 2,000 years. As people continue to study it, we develop newer and better technology. Things like the Hubble Space Telescope today, they have expanded our knowledge of space exponentially. All right,